If you look at the expansion board, this is the DS18X20 temperature sensor we used last time, and the blue one here is the DHT11. Although it says humidity, it actually measures both temperature and humidity. So, this time we will also display the temperature and humidity on the OLED display, just like last time. Please carefully place and secure this part, and then securely place and secure the module. This means everything is ready. I opened the code from last time. First, the first thing we need to do is import the Adafruit DHT Python library that was created to control the DHT11. If you look at the library here, there might be some people present, and even if there are, there may be some with empty code. You should create a new file named adaport_ext here. Please enter pi like this, p. This is the Greek letter pi, which is often used in mathematical contexts, especially in geometry and trigonometry, and is a fundamental constant in mathematics and is used in various calculations and formulas. If you move to this link, you will find the code here, which is essential for the next steps in our process. Click at the very end of the text, hold down the Shift key, and select to copy it, ensuring you have the entire code block, which is crucial for the subsequent steps and will be used in our project. Then paste it here in the designated area, making sure it is correctly placed and formatted to avoid any errors during execution. Next, let's input the code. Import the necessary code from the file. Then, from the USSD library, import the I2C module, and from the USSD library, import the SD module, which are essential for our operations and ensure compatibility with other modules. Additionally, from the USSD library, import the VCT module, specifically version 11, which is crucial for our operations and ensures compatibility. After that, we initialize the I2C, as we always do. Here, we initialize the mode, set the set key, and configure the MOSI, ensuring all parameters are correctly set for optimal performance and efficiency. Then, we proceed to initialize the display. Our parameters are 8, 6, 7, 6, 6, 3, 7, which are vital for the display configuration and ensure proper functionality and clarity of the output. After that, clear the display to ensure no residual data is shown, and finally, execute display, show to present the current data, confirming everything is working as expected and the display is functioning correctly without any glitches. Next, the DHT11 sensor, which is a basic ultra-low-cost digital temperature and humidity sensor, is connected to pin D6 on the microcontroller. This sensor is popular for its simplicity and ease of use in various projects. Ensure that the connections are secure to prevent any potential issues during operation. Please wait for approximately 1 second until it fully initializes and becomes ready for operation. After waiting for the sensor to initialize, which typically takes around 1 second, you can proceed with the data reading process. Then, in a while loop, since errors may occur due to various reasons such as sensor malfunction or communication issues, use a try statement during the operation to safely read the temperature data from the DHT sensor. In the while loop, it is crucial to handle potential errors that may arise from various factors such as sensor malfunction or communication errors. Using a try statement is a recommended practice to ensure that the program can handle these errors gracefully and continue to function correctly. After successfully obtaining the temperature reading, proceed to get the humidity data from the DHT sensor as well. Once the temperature data is successfully read from the DHT sensor, the next step is to obtain the humidity data. After that, output this collected data to the OLED display, which is a small, efficient screen used for displaying information in a clear and concise manner. This data is then output to the OLED display, which is a compact and efficient screen used for displaying information clearly. Since these are numerical values, wrap them as strings to convert them into text format, which is necessary for display purposes. Converting numerical values to string is necessary for display purposes, as it allows the data to be presented in a readable text format. Then, convert the string representation of humidity to text as well, and since the string for humidity is expressed in percentage, ensure it is formatted correctly like this. The humidity value, expressed as a percentage, should be formatted correctly to ensure accurate representation on the display. Finally, display this information on the screen, and also make sure to show these readings on the console in this manner, providing a comprehensive view of the data for monitoring and analysis purposes. Finally, displaying this information on both the screen and the console provides a comprehensive view of the data, facilitating monitoring and analysis. The current temperature and humidity levels are clearly displayed on the console screen, providing real-time data for monitoring purposes. In the event of an error, please press the designated button here to indicate the specific reason why the error occurred. This system is designed to update the information once every second, ensuring that you have the most up-to-date data available. Let's try saving it now to ensure everything is functioning correctly. This will help us verify that the system is operating as expected and that all data is being accurately recorded and displayed. Now, can you see the temperature and humidity displayed on the console? Let's check it on the OLED display. As you can see, the temperature and humidity are displayed here, just like we saw on the console. In this state, when I place my finger here, the temperature doesn't change much. However, the humidity does change, actually. In this way, you can retrieve temperature and humidity data using the DHT11 sensor. In this session, I worked on controlling the DHT11 temperature sensor using CircuitPython. I will return with another topic next time.